lot of confusions among the children regarding the pattern of examination, like how the students are selected and how it will be the percentile, how it is calculated. Certain doubts are there in the minds of children. Lot of teachers, lot of parents, lot of students, many people, many organizations, they come and forward and ask like how the percentiles are discussed and how the people are selected for the main. Like that, there are so many questions which the parents keep on asking, and the children also, they keep on asking. So few points I would like to clarify, and certain points which are not within my reach, I would not like to comment on them. Certain points like, for example, how many people will be selected from the total students who appear for the exam in the first stage. First stage, when I talk of it, is the IIT main examination. They say it is about 1,50,000 students will be selected from the total people who will write, including all categories. So reservations and non-reservations put together, they will be selecting around 1,50,000 students. Now there is no tie-breaking situation which is mentioned here. Therefore, the count may be a little more than 1,50,000. It may not be exactly 1,50,000. It can be 1,52,000 or maybe 55,000. This includes all categories put together, all reservations put together. This is 1,50,000. Now I just give you an idea as to what 1,50,000 means. Say last year a student who got selection into the IIT examination, say about a rank of 17,149 approximately. So his marks were about 143 out of around 400 marks. Now if you want the student to come in the 1,50,000, approximately, if you ask me, if he secures around 70 marks, I think it should be sufficient to get him into the 1,50,000. So once he is in the 1,50,000, then certain percentage of board is added, say around 40% of the board marks are added, and a merit list for AAAA is prepared. All the students 1,50,000, they will be appearing for the IIT examination, which is called as IIT Advanced Examination, which is again objective pattern with two papers, one in the morning and one in the evening, like the old IIT pattern examination we can see. From this, they will make a merit list, and once they are in the merit list, then based on the top 20 percentile, the students will be selected to the final selection list. That will be around 10,000 or 11,000, whatever be the number of seats, depending on the number of seats. These students will be selected in the final merit list. This is what is the process as of now it is given. Now if you are talking of percentile, how that percentile is calculated, say generally basically you are in the top 20% or not, that is the basic requirement. So now in that lot of things which have to be taken, say if one doubt is whether languages will be included, means yes, languages will be included, that is what is given on the IIT website. Then other than languages, then what else we have to do? The other than language means PCM is selected, PCM is taken into consideration, and then languages are also taken into consideration. If you are in the top 20 percentile means how that top 20 percentile is calculated, whether all the students who appear for the board examination will be taken, or only the students who appear for the examination will be taken, or the number of students who enroll for the board examination is to be taken. No clarification as far as that particular aspect is concerned. So once any clarification receives, that can be passed on to you. As of now, the PCM plus languages put together, the marks will be counted, and nothing is mentioned about all the students who apply for the intermediate examination will be taken, or all the students who apply for IIT will be considered, or all the students who apply for AAAA will be considered. That is, nothing is clarified as such. So as such, no clarification regarding that point. So therefore, once that clarification is received by us, I think, or by all of us, so I think that can be passed on to you. So any clarifications regarding this aspect, you can post it to us, or you can ask us, so that we will clarify in this regard also. Now I teach maths, so certain topics have been earmarked for me. So based on the number of teachers available, certain topics have been given to me. Out of these topics, one topic which I would like to start is functions, and this particular chapter will have a lot of importance in the exam. At the same time, a lot of clarifications are required regarding this particular topic. And once we start off with the topic, so my expectation is you concentrate well on the lecture, and whatever I write on the board, that can also be given as a downloadable content. So therefore, instead of concentrating on copying the things what I write on the board, it is better you listen to the lecture first, and once the questions can be taken as a downloadable content, and then even the solutions also can be provided to you. Therefore, rather than copying what I am telling, it is better you listen to what I am telling. Once if you feel that it is comfort level is good, then you can write down and also listen to the lecture, but concentration is first to listen to the lecture. Now when I am talking of the chapter functions, now a lot of confusions in the minds of students, so those confusions I try to clear. And one more point I would like to mention is the mathematical rigor which is required, so that rigor I am removing it and making the chapter in a much lucid way, and I expect all my colleagues, all my seniors, all my teachers, all my friends, if I am missing the mathematical rigor, don't blame me for that. My intention is only to reach to the students more, and I want to make the content in such a way where even a 7th class boy attends my lecture, he should be able to understand the topic of functions well. That is the main idea behind this lecture. Any clarification required can be taken. More rather than complicated notations, complicated definitions, all that I have taken out of it and then made the chapter in such a lucid way where anybody attends this lecture, even from a rural background also, he should be able to understand the basic content and he will be able to do problems in functions well. Now, before we define what is a function, so I would like to just start something before functions and then get to the definition of function. So therefore, I would like to comment on certain aspects and then get to the topic of functions. So before that, I just go to the board and write down few things. If I am writing, say y is equal to x square, or say y is equal to x, or say y is equal to root x, or x is equal to y. I am writing a relation between two variables. One is a dependent variable and one is an independent variable. So generally, like in maths, we don't give any significance to the variables as such. We only talk of the variables only as x and y. What is x and what is y, we don't talk about it. Suppose x is time, or what is y, is it displacement, is it velocity, nothing is said in maths as such. We only write it as an equation. So therefore, by convention, whatever we write on the left hand side, we take it as a dependent variable, and whatever we write on the right hand side, we take it as an independent variable. Just for clarity's sake, if you take a graph x-axis and y-axis, whatever we plot on the x-axis, we take it as independent variable, and whatever we plot on the y-axis, we take it as dependent variable. But remember this may not be true always. X is equal to y means, suppose if I want y as a dependent variable, I'll write y is equal to x or x is equal to y if I define what is independent and what is dependent. Nothing is defined, we just write it as y is equal to f of x or y is equal to x square. That means whatever I write on the right hand side, that I take it as independent variable as a matter of convention, and whatever I write on the left hand side, that I take it as a dependent variable. Now when I am writing y is equal to x square, I give an input, say for example x is equal to 2, so I get y is equal to 4. I am giving an input to the independent variable and I am getting an output for the dependent variable. So given an input, I am getting an output. So the output is 4 and the input is 2. That is the output which I am getting. Now instead of this, suppose if I take y is equal to plus minus under root of x. Now here, if I put x is equal to 4, I get y is equal to plus minus 2. So that means for one input, I am getting two outputs. This is a common problem which we face, whether we call it a function or not a function. When a single input is given, when I am getting two outputs, generally we say it is not a function. Now if I say this, whenever I am getting a single input, single output, this I call it as single valued functions. So the output is only one, and this is multiple valued. So fortunately or unfortunately, we will not be dealing with this multiple valued functions, we will be talking of only single valued function. This is first restriction which I apply in functions before we proceed further. So this is the first thing which I have written. Second thing, when I write y is equal to x square plus 4, I am writing a function where I have one dependent variable, one independent variable. That means this I call it as a single variable function. Single variable function. Whereas if I write z is equal to x square plus y square, here one dependent variable and two independent variables. This I call it as a multiple variable function. Multiple variable function. Now again, unfortunately, this multiple variable functions are not there in the syllabus for JEE. We will not be dealing with. Certain boards, they have in their +2 level multiple variable functions, maybe partial derivatives, but in JEE level we don't talk of this multiple variable functions as such. Therefore, this also I have excluded. I am talking of only single variable functions. If you take some standard textbooks, like you take I.M. Aron, he'll write the heading as calculus in one variable. That means this is the one. He's talking of only one dependent variable and one independent variable only is talking of, and that is what is calculus of single variable or a single variable function. That's what we talk of. Now I talk of a third restriction here. Suppose I have a function like y is equal to under root of x minus 1. Now if I give a value x greater than or equal to 1, so y will be real. So this is a real valued function. If x is less than 1, that means y is imaginary. So again, imaginary valued functions will not be dealing with, we will be talking of only real valued functions. Now at the backdrop, I am putting three restrictions. Number one is single valued function. Number two, I am putting a restriction single variable function. And number three, I am putting a real valued functions. So with this restrictions at the backdrop, I define a function now. Okay, I define a function now. Now if you look at this definition, focus on the definition. Function is a rule which will assign to each element of set A one and only one element of set B. This is what I am defining it. Set A is called the domain of the function, set B is called the codomain, and range is the subset of the codomain. This is what I am defining. Once I define this function, that means what? I am talking of two sets, set A and set B. Set A I call it as a domain and set B I call it as codomain. And range is the subset of the codomain. What are these? We will discuss a little later now. Now, based on this definition, we go ahead. I just draw two diagrams here. So this is set A, this is set B. Now, one element in set A, I am giving two images here, two outputs. Based on the definition, one and only one element of set B, if I go that, this will not be a function. So this is one diagram where you should remember it is not a function according to the definition which we gave. Second thing, I draw one diagram again, three elements in set B and four elements in set A. Now I just give a mapping here like this. Leave one element vacant in set A. Now again, if I go to the definition, is a rule which will assign to each element of set A. That means there cannot be any element vacant in set A. That means if there is an element vacant here, again this is not a function. So if these two aspects are taken care of, and if these two aspects are understood properly, any other diagram you draw a relation between A and B without involving these two, you get a function. Suppose I write like this. Now I have here some elements, say three elements, and here I have one element. Now I can say it is a function. It is not one amongst these two. If it is not one amongst these two, definitely it is a function based on the definition which we have given. Now in this aspect, like say for example, if I am taking this as a function, say this is the domain and this is the codomain I am talking of. Now we get back to the definition of domain to understand further. The domain definition, it is given in such a way where the conventional definitions given in textbooks is done away with. What I am giving is whatever anyone can understand, that wordings I have put here. Suppose I have a function y is equal to f of x. Now y is equal to f of x means a function which is given, whatever input you can give to the function is the domain. That is what I have defined there. Whatever input I can give to the function means the input is always given to the independent variable. So whatever values x can take, if that is the independent variable, then based on the input, whatever output I get, that output is taken as range. But anyhow, range is next point which we talk of. First I am talking of domain. Whatever input I am giving to the independent variable, that input is nothing but the domain of the function. Now the question comes, what is that I cannot give? That is the next question which I get. That means if I am wanting to calculate the domain, I have to take into consideration two aspects. Number one is the function should never become indeterminate. That is the first aspect which I am looking at. And the second one is the function should never become imaginary. These 2 points I have to take care of before I start finding the domain of a function. Now function should never become indeterminate means what are indeterminate forms that I am supposed to understand before I proceed further. Now indeterminate or not defined. Again there is a discussion again on this. Now what is indeterminate and what is not defined? So I mean in our sense if you take both as same, nothing wrong, but basically there is some minute difference between both them. Not defined, indeterminate. Indeterminate means what? There cannot be any value which you cannot find out. Not defined means no value exists because not in the domain of the function. So this is there is a minute difference between both and we don't worry about them at this point of time. Without that we proceed further to talk of. Now when I am writing a function y is equal to f of x, so you find in books 3 kinds of notations which people follow: f, a to b, f, then y is equal to f of x. Now notation really worries a lot of people. If notation is not proper, obviously there will be some disturbance in the minds of the children before they proceed further. Now sometimes they call function, sometimes they call map. Map is nothing but a pictorial representation or a pictorial diagrammatical representation. So whether it is written like this or like a diagram, it means the same. Now f a to b, I can call it as a function. A maps to b. That means in this case a is the domain and b is the codomain here I talk of. Here also a is the domain and b is the codomain, and here x is the domain whereas y is the range. If I am writing like this, domain codomain, and then range and codomain, that is what is happening here. So the notation should tell you what exactly the output is. Whether the output is totally contained in set B or certain elements are left over, that has to be seen. But no element of set A can be left vacant. That is the rule which we have to follow. So that means I talked of 2 things. The function should never become indeterminate and the function should never become imaginary. The function should never become imaginary because in the initial stage only we had put a condition that we are talking of only real valued functions. That's the reason why wherever the function goes imaginary, those values have to be taken out. That means if I take any function y is equal to x to the power of 1 by n. Now if n is odd, say for example I take 1 by 3, then even I can give negative values where the output will be a real number only. Whereas suppose if I have like this y is equal to x power 1 by 4, then I cannot have x is equal to negative. That means all the negative values in the root which is an even root should be eliminated before finding the domain of a function. Now when I am writing y is equal to x power 1 by 3, in that case I can give any value. Suppose I have a function like this, f of x is equal to cube root of 1 minus 3x. Now this can be negative, therefore the domain of this function can be any set of real numbers. When I am talking of set of real numbers, I am talking from minus infinity to plus infinity open interval. This is R which I am talking of. From this I can give any input to the function and that function will give some output if that particular point is in the domain of the function. Now what is imaginary means? Basically any square root, 4th root, 6th root, 10th root should not have a negative value inside it. If there is no negative value, in that case we say the function is giving you real value, otherwise it will give you imaginary value. Because imaginary valued functions we are not dealing with, we will be talking of only real valued functions. Now the first point which I talked of, the function should never become indeterminate. Now I just go to the slide here, you look at this, what are indeterminate forms? Yeah, you look at these indeterminate forms. So indeterminate forms, I have put a heading and I am writing certain things over there. The first thing which I wrote is 0 by 0, not defined. Infinity by infinity, not defined. 0 into infinity, not defined. 0 power 0, not defined. Infinity to the power of 0, not defined. Infinity minus infinity, not defined. 1 power infinity, I have put a star before. It is actually not indeterminate, it is a determined value, it is equal to 1. 1 by 0, again not defined. Again 1 by infinity is equal to 0 plus. And again, like that, I have given all the determinate values. 1 by 0 plus I have given. If you see here, 1 by 0 is not defined. 1 by 0 plus is plus infinity, and 1 by 0 minus is minus infinity. I have written here. To only show that 1 by 0 is not defined, 1 by 0 plus means a value which is closer to 0. And if you divide 1 with a smaller value, like say for example, 1 by 0.1, 1 by 0.01, 1 by 0.001, and if you extend it 1 by 0.000 so on up till 1, it will be definitely a huge number which is closer to infinity or which is equal to infinity. That is what I talk of. Now, like this, I have defined all the indeterminate forms. Whenever we look at these forms, say for example, there was once a question given with 0 power infinity. That also I have included there, and I have put a star over there. 0 power infinity is equal to 0. Based on that, a question was asked some time back. People were getting a confusion whether 0 power infinity is indeterminate or 0. It is definitely 0, that has to be taken. Now, infinity plus infinity is equal to infinity. Infinity into infinity is again infinity. Log 0, again there is a confusion. Log 0 and log 0 plus, if you take, log 0 is not defined and log 0 plus is minus infinity. If you take the domain of the function log x, it is x is greater than 0, not greater than or equal to 0. And therefore, when x is greater than 0, in that case, log 0 plus is minus infinity. If you look at the graph of log x also, it is very evident. That means what? It is going to be minus infinity only when it approaches 0, not exactly 0. Therefore, these are the points which I have written. Log 1 is again 0. Log 0 plus is minus infinity. So, these indeterminate forms, you be clear with it. Yeah, just there is a call I would like to answer.
Hello.
Yeah.
Can sir explain that 1 power infinity? Sir has given 1 power infinity as 1.
Yes.
But I am having a doubt.
Yes.
In some books, 1 power infinity is given as undetermined form.
Okay.
I need more elaboration about it.
Okay, I'll just go through it. I'll take this call, and it is definitely a confusing point to a lot of students. Maybe in some books they are writing it as 1 power infinity as 1 in some books, and some books they are writing 1 power infinity as not defined. Now I tell you, when you deal with limits, say for example, I am talking of limit extends to infinity a power x. These kind of questions, you will be getting at the form 1 power infinity as a limiting case. It all depends on the value of a. Suppose if a is equal to 1, then this value will be definitely 1. If a is greater than 1, so that means in that case, it's a value which is greater than 1 means what is increasing and it is unbounded, therefore the value will be equal to infinity. Now, if a is less than 1, that means what? Say basically I am talking of mod a less than 1. In that case, the answer will be 0. Now the remaining part which is left out is a less than or equal to minus 1. If you take this here, the value will be oscillating, and therefore I say here limit does not exist. Does not exist. Now taking this at the backdrop, now in the limiting form, like say for example, limit extends to 0, 1 plus x whole power 1 by x, we write it as e. Similarly, limit extends to infinity, 1 plus 1 by x whole power x, also we write it as e. Here there is a difference here, it is not exactly 1, it is approaching 1. People confuse this with a is equal to 1. This is not exactly equal to 1. This is approaching 1. If you take a value slightly greater than 0 or slightly less than 0, but that x will never be 0 because we are calculating the limit. In the limits, if you talk, that will be an indeterminate form, whereas in the case of exact value 1 power infinity, it should be taken as 1 for sure. This is to be noted, and in future any such confusion comes, you take it as a power x is equal, limit extends to infinity is equal to 1 if a is equal to 1. This has to be taken. I think your doubt is clarified. And any such students you have such doubts, you can always ask. We'll proceed further with the class. Now these indeterminate forms, once you are clear with this, now we are ready to take problems based on indeterminate forms or based on the domain of the function. Now I take a question like this, y is equal to x square plus x plus 1. I have a function. Now, if I take this function, whatever value of x I want, I can give to the function. That means basically x can take any value, whatever value I give, y will be defined for that. Therefore, I can write x belongs to R. Now, suppose I have a function like y is equal to 1 by x. That means here everything it can be given, but x not equal to 0. Like this I can give the function. Similarly, I may get functions like this, under root of x square plus x plus 1. Now again, this is defined for all values provided the value which is inside the root should be always greater than or equal to 0. Now x square plus x plus 1 should be greater than or equal to 0. Once x square plus x plus 1 is greater than or equal to 0, it will be defined for all values. Now x square plus x plus 1 is greater than 0 or not, or for what values it is greater than or equal to 0, that I am supposed to know. Once I am clarified with this particular aspect, I will be sure of solving the questions further now. Now x square plus x plus 1 greater than or equal to 0, if I just take the discriminant of this, I will get b square minus 4ac is less than 0. So b square minus 4ac less than 0 and the coefficient of x square is greater than 0. That means if I look at a graph of this, it always above the x-axis. Means it is always positive. Therefore, this is defined for all values of x because the inside quantity is always positive whatever value of x we give. Now therefore, the domain of this function is also x belongs to R. But this may not happen every time. There may be values where there may be functions where the inside quantity can be negative. Therefore, the most important aspect before we proceed further is solving inequations using the number line technique. So this one aspect you have to understand. I advise all the students to practice at least 10 to 20 questions on this before you take on further the topic of functions. I am uploading one assignment consisting of 30 questions without answers, and you solve them and get back to us. We provide the answers. Anyone who can solve these 30 questions, you will never have problem as far as inequations are concerned. Sure, I have put some simple questions, some difficult questions, some very difficult questions. If anyone is able to solve all these 30 questions, that means what, you are sure of inequations as far as these expressions, algebraic expressions are concerned. Now, I expect all the students to download this content and then solve the questions. I will give you a few examples as to how to solve inequations. Now, I take a question like this: y is equal to under root of x square minus 5x plus 6. I am interested in finding out the domain of this particular function. So my restrictions for this domain is what? X square minus 5x plus 6 should be greater than or equal to 0. I am solving an inequation for x square minus 5x plus 6 greater than or equal to 0, and if I have to solve this, I am using a number line technique. So what I do is I just draw a number line, right, and equate this to 0 and find the roots. X is equal to 2, x is equal to 3 are the roots. So x is equal to 2 and x is equal to 3 are the roots. That means I'll put these roots on the number line. I just hold this question for a while. I just take a call. Yeah, please go ahead.
Right. You have said that x square plus x plus 1 is b square minus 4ac less than 0.
Yeah. B square minus 4ac less than 0, yes. The voice is not audible.
So that value should be imaginary now, sir? Discriminant is less than 0, then value should be imaginary now.
No, the question is not clarified, but anyhow, whatever I understood from your call, I'll try to explain that. Just look at this, I'll tell you. See, whenever you have a quadratic expression like this, ax square plus bx plus c, right? If a is greater than 0, the graph will be opening upwards. It may be cutting the x-axis, may not be cutting the x-axis. So you may have like this also, or you may have like this also. Now if this is the situation, a is greater than 0 is common for all the three. Now in this case, discriminant will be 0. That means two roots will be real and equal. In this case, no roots. Therefore, d is less than 0. This is the second case. Third case, here d is greater than 0. Discriminant is greater than 0. If you look at this, in all the three cases, the graph is opening upwards. Now our question which we took there was x square plus x plus 1, y is equal to. Now calculate the discriminant, b square minus 4ac is less than 0. That means definitely it should fall into this particular category. So if it falls into this category, now because a is greater than 0, I have opened it upwards. I also can talk of situations like this depending on the question. If a is less than 0, the first case will be analogous to this, like this. Here d will be 0. And whereas here it will be like this. That means what? D is less than 0. And here in this case, d will be greater than 0. Now I expect you to look at all these 6 graphs. D0, D0, a greater than 0, a less than 0. A greater than 0 means what? Basically opening is upwards. And a less than 0, opening is downwards. In both cases, d is equal to 0. This will be always negative, this will be always positive, including 0 value also it will take. Whereas this will always be positive, this will always be negative. Whereas this will be partly negative, partly positive, partly negative, partly positive. I am coming to your question means basically you have to understand the question which was given to you was y is equal to under root of x square plus x plus 1. Therefore, x square plus x plus 1 is greater than 0 or equal to 0 also. Equal to 0 doesn't arise because it will never be equal to 0. Because this is the situation which I am talking of. Therefore, it can be given any value of x, still the function becomes real and therefore the domain of the function is R. I hope your doubt is clarified. Now, what I do is these kind of questions will solve one or two questions. Like you look at the other question which I was trying to solve. I think you should understand this. Remember the 6 graphs which I have drawn. This I will try to send it as a downloadable content so that you can look at all the 6 graphs. Now I was talking of y is equal to square root of x square minus 5x plus 6. This is what I was talking of. Now x square minus 5x plus 6 is greater than or equal to 0. And now if I put a number line, I have solved the roots for this. They were 2 and 3. This is minus infinity. This is plus infinity. Now any equation like this if you get, you equate it to 0 and solve this. Whatever roots you get, you plot them on the number line in the ascending order. Once you plot them in the ascending order, the number line because of 2 roots is divided into 3 portions, 1, 2 and 3. From this portion, you take any one number of your choice. Suppose I take x is equal to 0. Now 0 lies in this particular interval. I will substitute 0 here. I will get 6, that is positive. This whole interval will be positive. Now alternately it will be negative, positive. Therefore if this is positive, this is negative and this will be positive. Now the whole number line is divided into 3 parts. 2 parts are positive and 1 part is negative. Now what I want is greater than or equal to 0. Therefore wherever I am getting greater than or equal to 0, that particular aspect I will take and that will be my solution. Now my solution will be x belongs to minus infinity to 2 union 3 to infinity. Now if I am putting a square bracket means the 2 also can be included and this 3 also can be included. Now if the question is like this, (1 by x square minus 5x plus 6). In this case, everything remains the same. Only thing is the solution does not include 2 and 3. That means 2 I will put in the open interval and 3 also I will put in the open interval. So once it is there, in that case, the difference between both of these questions is here I can include the value of function so that it becomes 0 also. Here it cannot be 0 because 1 by 0 is not defined. So we take up 1 or 2 questions like this and then the assignment which you get, you will be able to solve them. I may be talking of situations where some roots are real, some roots are imaginary. Say I have a question like this. Y is equal to x square plus x plus 1 into x minus 1. Suppose I have a question like this inside a root. Now, we have just seen this is always positive. That means what? That is always going to give me positive value. I can ignore that and I can take only this particular condition. X minus 1 should be greater than or equal to 0. This is always positive. Always positive means what? This also should be always positive. Suppose if this can be negative, I can also consider this negative. Because this is always positive, I only consider x minus 1 to be greater than or equal to 0. Therefore, x is greater than or equal to 1 is the domain of the function. Suppose I take a function like this, y is equal to x square plus 1 by x minus 1 into x minus 2. I have a function like this, say square root of this. Without square root is very simple, x is not equal to 1, x is not equal to 2. With square root it's slightly complicated. So what will I do? X square plus 1 by x minus 1 into x minus 2 should be greater than or equal to 0. Now because this is always a positive quantity, I'll just cross multiply to the other side and it will be equal to 0. And therefore, I'll write it as 1 by x minus 1 into 1 by x minus 2 is greater than or equal to 0. Now, if I look at this, I'll write like this, x minus 1 into x minus 2 by x minus 1 whole square into x minus 2 whole square greater than or equal to 0. I am multiplying with x minus 1 into x minus 2, both numerator and denominator. Now because this is a positive quantity, I'll just cross multiply to the other side and write it as x minus 1 into x minus 2 greater than or equal to 0. But I put a restriction here. The restriction is x is not equal to 1, x is not equal to 2. This restriction is must. If I am cross multiplying here, that means what? I am assuming that x is not equal to 1, x is not equal to 2. Therefore, if I don't put this condition, my question will be wrong. And therefore, once I put this condition, now my question is same like the earlier question which we solved. I just go with a number line. 1 and 2, I put them. Now take any value, say x is equal to 0, I take. So positive, negative, positive. Okay, so my answer would be x belongs to minus infinity to 1 union 2 to infinity. That means 1 and 2 I put in open interval so that I eliminate these conditions or I take this condition into consideration. X is not equal to 1, not equal to 2 is automatically taken care of and my answer would be minus infinity to 1 union 2 to infinity. And this is what is the solution for this. Now, we'll take one more case. Solve 1 by x greater than 1. Generally what people do is cross multiply immediately and write it as 1 is greater than x, therefore x is less than 1, they write. If I write like this, I am assuming that x is positive. Only in that case only I can cross multiply, otherwise I cannot cross multiply. Either you take two cases, x is greater than 0, x is less than 0, or you can solve the question in one stroke also using number line. What I do is get that 1 to this side. 1 by x minus 1 is greater than 0. Now I'll take LCM. 1 minus x by x, I'll make it x square and multiply by x and greater than 0. Multiply and divide by x. So this will be x into 1 minus x is greater than 0, where x is not equal to 0 is the condition which I am putting it here. So once I put this condition here, I can easily write down the number line 0 and 1. So now I take any value because 0 is already plotted here, I don't take 0, some other value I take, say for example I take 3. If I take 3 into 1 minus 3, which is nothing but a negative value. Therefore, this is negative, this is positive, right? This is negative. So my solution is greater than 0, therefore x belongs to 0 to 1. This is the answer. Now here I would like to throw some light into this kind of questions. Suppose you have a number line. I have roots like this, say 2, 3, and the equation is x square minus 5x plus 6 greater than or equal to 0. Some people what they are doing is they are teaching that okay, you start from the last, put plus, minus, plus. Like this you go and you get the answer. But this will sometimes fail whenever the coefficient of x square is negative, that particular equation fails. See, for example, if you look at this question here, x square coefficient is negative. Therefore, here this is negative, this is positive, this is negative. Therefore, my advice is instead of going haphazardly, you can just take one value and check for one interval and then put alternately plus minus, that would be better. If you want to go like this, you have to ensure that that particular interval, the last interval is always positive, means x square coefficient or x cube coefficient or x power 4 coefficient, that should be positive. Otherwise, it will give you a wrong answer. Therefore, I don't recommend this like this, starting from the last, putting plus minus alternate. I don't recommend that. Instead of that, you better take some value and substitute and then verify the answer. That would be a better method. So we take up one more question where you have like this. F of x is equal to x minus 1 into x minus 2 by x minus 3 into x minus 4. Find the domain of the function. Now it looks terrible if you have to solve independently. If you solve this using number line, the question becomes very simple. So I want x minus 1 into x minus 2 by x minus 3 into x minus 4 to be greater than or equal to 0. Now multiply and divide by x minus 3 into x minus 4 so that the denominator can be taken out. Is greater than or equal to 0 with a condition x is not equal to 3 and not equal to 4. These restrictions I put. Once I put this restriction, now I am ready to solve this question. These are the ones. Now once I have them, I plot the number line. So take any one value, say x is equal to 0. If I put x is equal to 0 here, 0 lies in this particular interval. Now this is negative into negative positive, negative into negative, this is positive. Therefore overall it will be positive. Okay. Now this will be negative, positive, negative, positive. So now my requirement is greater than or equal to 0, excluding 3 and 4. So my solution will be x belongs to minus infinity to 1, where 1 can be included, union 2 can be included, 3 to be excluded, open interval, union 4 to be excluded, 4 to infinity, and this gets me the answer. So now my advice is solve as many questions as you can before you proceed further to the next unit. So my advice would be the assignment which I am putting on in the downloadable section, you go through that assignment, solve every question. Don't think all the questions are simple. You solve all the questions. That will give you an absolute clarity as far as the equations are concerned. A lot of students, even getting to the final year, final stage also, they'll have some problems in solving equations like this. It requires a little practice, and with the practice you can solve the question. So I take one more last example. You can just go through it. Say I have something like this. 1 less than x square minus x minus 6 by x square plus 1 less than 2. Now I am looking at two inequalities simultaneously. So first thing is what? I take x square minus x less than 2 into x square plus 1. This is one equation I solve, which will be nothing but x square minus x minus 6 less than 2x square plus 2. Now there will be a small confusion here. Why I have cross multiplied? I can cross multiply because x square plus 1 is always positive. Therefore, because it is positive, I have cross multiplied it. Then this is one equation I am solving. The second equation will be x square plus 1 is less than x square minus x minus 6. So this is one equation I am solving, and this is the second equation I am solving, and solve both of them, and the intersection of that will give me the answer. So my advice for such questions is individually you solve the inequality and then you take the intersection of both, and that will give you the answer. So one more example which will help you in solving the equations. There may be questions like this also. X minus 1 into x minus 2 by x minus 3 into x minus 4 greater than 1. So in this case, solving this question, you cannot cross multiply directly. If you are cross multiplying, you have to take two situations. Therefore, my advice is write it as minus 1 greater than 0 and solve this, and that will be the question. Now whatever inequations we are solving, these are all based on algebra only. I can have questions based on trigonometry, I can have questions based on logarithms, I can have questions based on inverse trigonometric functions, I can have questions based on step functions, I can have questions based on fractional part of x, any of the functions which we define. So whatever be the different kind of functions, we discuss them in the next class. Before that, we talk of modulus function and then greatest linear function. All the functions we'll be talking of, and based on those functions we'll be able to find the domain properly. So one small question before we depart. Look at this question. F of x is equal to 2 power sine inverse x plus 1 by x plus 1 by square root of x minus 2. Say this is the function given. Now this question is comprising of 3 parts, 1, 2, 3. Each function I take separately and try to solve for the domain. So this is what sine inverse x means. The domain of this function will be minus 1 to 1. This is the first part. Second part, the domain is x is not equal to 0, and the third part is x greater than 2. X greater than 2. If I take the intersection of these two, I will get minus 1 to 1, x not equal to 0. If I take the domain of these two intersections, there is no intersection. That means overall the intersection does not exist. Therefore, x belongs to null set, and that will be the domain of the function. So that means what? You are talking of 3 functions independently. Each function domain you are writing, and based on the each function domain, we are calculating the intersection, and because there is no intersection, I will get the answer as null set. You can try this question also. F of x is equal to tan of pi into x minus pi by 1 plus x square. This bracket, whatever I am writing, it is the greatest integer function of x. Now I have not defined greatest integer function of x, but greatest integer function of x we will be discussing in the next class, but I just give you a brief idea about this. It will take the output as only integers, and it will take only integer value. Denominator is always defined, and the numerator is always tan n pi, which is equal to 0. Therefore, the function becomes f of x is equal to 0. So once f of x is equal to 0, it is a constant function defined for all values of x. Therefore, the domain is x belongs to R, and the range of the function is a singleton set. Now quickly we sum up the things I have defined. In what situations we will be talking of. Yeah, one call I am taking.
Look, sir, you have said that is we have to solve the both independent and we have to take intersection. But why can't we take common, sir?
Comment? Why can't we take
common of those two solutions?
What is common of those solutions? Basically, intersection means what?
Intersection
means what? Suppose, for example, I write this set A, I write 1 to 2. Set B, I write 1 to 4. What is common? Can you see this?
Yes, sir.
What is common?
1 to 4, sir.
1 to 4 is common?
Yes, sir.
1 to 4 is common. 4 is there in the first interval?
No,
not there. What is common now?
1 to 2.
1 to 2 only. What is that 1 to 2 called now?
Solution.
Intersection. That is called intersection. You understand now? So intersection means what is common. That is intersection. Right?
Thanks.
Yes. Okay. So when we are looking at this question, intersection union, when next class when we take up, in that I will just throw a little more light. There may be students who have some basic problems in understanding what is union, what is intersection. I actually wanted to do this program in the local regional language, but because there may be students who don't understand the local language, I am looking at only a language which is common to all. I will see if this can be translated so that the students can understand the language better rather than the problem. The language should not be a constraint. We will see if we can translate this into Telugu and try to put as a downloadable content. We will just see if this is possible.